Good afternoon, students. Good afternoon. Okay. So yesterday we were doing some chemistry sums. Fine. So we'll continue from there. Okay, fine. So today, we'll continue with electronic configuration. So we'll do some sums on electronic configuration. Very, very important, right? See, in chemistry, electronic configuration is the most important. Now, if we want to, fill the electrons, right? There is a particular way. We have discussed in the Zoom class. Certain rules are there. So first rule is Obbaw's rule, right? Okay. So I think we will not discuss it here. We already discussed. Obbaw's rule states that your energy should be very less. You should fill first lower energy, right? First fill the lower energy orbitals. Okay. Yes. Then you fill the higher energy, right? So first lower energy, right? Then you fill on the higher energy. Now, students, actually, there is a simple, shortcut way for this. Uh, we will just write the shortcut way. The shortcut way is you draw like this: 1s, just see, 2s, 2p, 3s, 3p, 3d, fine, 4s, 4p, 4d, right? Just give me 1 minute, 1 minute, 1 minute, just give me 1 minute. Okay, Swan, just we'll start now. So 4s, 4p, 4d, 4f. Okay. So we'll just draw all the orbitals now. 5s, we'll draw all the orbitals: 5p, 5d, 5f. You can show 6s, 6p, right? 6d, 6f, 7s. Now, students, actually 7d, 7f is, listen here, not required. Why? Because we have in nature, like we have still only 118 elements. Okay, that you might have done in the like periodic table, right? We have only 118. So I don't think 70, 7f that much is not required, right? Okay. So now, how will you fill the electron? Just first you will fill the 1s. Okay. Listen to this very carefully. Very, very important. Then you will fill the 2s. See, it goes like a snake, like, okay. Then you fill the 2p. Correct? Fine. So let me repeat now. First you'll fill the 1s, then 2s, 2p, 3s, 3p, 4s. Then you will fill the 3d. Now this is a shortcut way, like you need not remember any rule and all that, right? So, very short way of filling electrons, right? Okay. Fine. So this is how you fill. So first 1s, then 2s, 2p, like that. You keep going, and I've drawn the arrow like for your 4d, right? 5p, 6s, keeps on going, right? Okay. Now, very important. What is the capacity of s orbital? 2 electrons. S can take only 2. Okay. Actually, we draw only one box for S. We'll fill 2 electrons here. One clockwise, listen here. One clockwise and one anti-clockwise. One spin is clockwise, one spin is anti-clockwise, right? So S for S only one box, only one orientation. So maximum you can fill how much? 2 electrons, right? Okay, so now coming to p orbital now. P orbital, remember there are 3 orientations. What are the 3 orientations? Tell me. Px, Py, Pz. There are 3 orientations for P. Px, Py and Pz. So now in each box you can fill 2. Maximum, I am telling maximum, remember. This is the maximum I am drawing. Okay. So maximum in each box you can draw 2. So 2. So total you can fill how much? 6 electrons, right? In p orbital you can fill. Maximum I am telling. Okay. Yes. You can fill 6 in the p orbital. 2, 2, 2, right? Then D. D you can have 5 orientations to only. Yesterday we discussed this. You can have 5. So 5 means, like, can you guess how much we can fill? 5 means maximum you can fill 10 electrons, right? So D la வந்து 10 electron maximum. Similarly for F, there are 7 boxes you can draw. So F will have 7 orientations, right? So students, maximum you can fill is 14 electrons you can fill. Is that clear? So if you know this, you can start filling electrons now. Okay? S can take maximum 2. P can take maximum 6. You can't do more than 6, right? D can take maximum 10. Okay, in one box only 2 electrons, please remember. Okay? And there's one rule for that. We've already done that, right? And F can take maximum 14 electrons, right? Okay? So students, just note down this, right? If you know this, you can start filling the electrons. And please remember this diagram. This diagram is highly helpful. Okay? Fine. Now let us do one thing. Let us do an example now. Okay? Let's do an example. Fine. Suppose students, I have got, I have got 40 electrons. I have got 40 electrons with me. Let's see how to fill it. Okay? So students, first I'll fill what? 1s. Listen to this very carefully what I'm doing. 1s. Then what will you fill? 2s. Then what will you fill? 2p. Just go by this diagram strictly. Then what will you fill? 3s. 3p. 4s. Okay? Now we'll do one thing, we'll put the electrons also. We'll know that 40 means where it comes, like. Okay? One is, as I told you, S can take maximum how much? 2. Am I right? Maximum 2. S can take maximum 2. P can take maximum 6. 2. 6. 2. Now, so just count. Are you getting what number? Just check. 10, 12, right? 12 plus 6. Am I right? 18, 18 plus to 20. 20 you have got now. 20 means you have to go further. You have to fill 40 electrons. So 4s. Then you go for 3D. Okay. 3D 10. Or 30 is over. 4p 6. 5 is 2. And then after 5 is you are coming to what? 4D. Now students wait for some time. Now just check, have you filled 40 now? 10, 12, 18, 20, right? 20, 30, 30, 36, 38, 36, 38. 38 you have filled now. 38, right? Now left is 2, so you have to write 4D2 only. Maximum is 10, but you are going to fill only 2. Okay? So now just check. It's 40 electrons are filled in this, right? Okay? That's how you'll do this question. Very important. Fine. Now the last electron, listen to this one, very important. The last electron is going to the d orbital. Okay, so it is called d block element. This will come in the d block. In periodic table, you might have done s block, p block, and all that. So if the last electron, okay, goes to the d orbital, it's called d block. So I hope you are getting it. Okay, so this is how you'll fill it up. Okay. You can write, so it's very important, you can write a short way of this. You know how to write a short way? Helium, write the inert gases. Inert gases are very stable. Helium, neon, argon, krypton, xenon, radon. Okay? Let me write the atomic numbers now. Helium is 2, neon is 10, argon is 18, krypton is 36. Okay? Then you can write xenon. Xenon you have to fill 36 plus 32. So it will come out to be how much? 68. Anyway, we don't require all that. Krypton, xenon, radon. Now students, you just check 40. 40, listen to this very carefully. 40 is very close to 36, am I right? After 36 will, so what you can do is 36 electrons, for 36 electrons you just write krypton, that's it. Write the whole thing, like 36 you just write krypton. Now let's check 36 ends where, let's check it out. 10, 12, 18, 10, 12, 18, 20, right? 30, 36. This is all is 36, just see now. This will be full 36. Okay. So instead of writing this whole thing, you can write a shortcut way now. You can just write krypton. This whole 36, right? So what you can do is, you can write krypton and then write these things, right? 5s2, 4d2. Okay. So this is an easier way of doing it. Why we are doing like this? Because it's an inert gas, noble gas, right? So anyway, this noble gas electrons, right, will not participate in bonding. Okay, krypton electrons, no, noble. Only these two are going to do chemical bonding, right? They'll participate in bonding. Fine. So we are showing only these electrons, which are very important for chemistry, right? It's important for bonding. Fine. So all that 36 will, this krypton will club all the 36, right? Clear? So in this way you can write. So just I'll pause for some time. Just see. Have you understood? Okay, students, have you understood this? So this is how you will write the electronic configuration, right? So you will write this as a D block element. Okay, fine. So I hope you understood. You can write this for any element, right? Okay. Fine. Now, next thing is, I will tell you some rules actually. Just see this. These questions are very important. Based on these rules, students, you will get questions. Listen to this very, very carefully. First rule is Obbo's rule. This rule states that you should fill the lower energy first. Okay. Now, how do you decide the energy? N plus L. I have told you this in the Zoom class also. Okay. N plus L you take. Lower the value of N plus L. If this value is less, energy is also less. Okay. Energy will be very low. And students, you will fill that first. Let's take some examples. Let's take 4p and let's take 5s. And let's decide, which will you fill first, 4p and 5s, right? Now, what is the N plus L value for this? N plus L is equal to 4 plus. Remember, what is the value of N here? 4, right? 4. What is the L value for p orbital? Like yesterday I told you, L is equal to 0 for s orbital, right? L is equal to 1 for p orbital, L is equal to 2 for d orbital, right? Am I right? So p orbital, am I right? L is equal to 1. So what is the value here? 5. Okay. L is equal to 1, right? 4p. Fine. Now let us do 5s. 5, what is the n value here? 5. And for s orbital, L is equal to 0. Now students, this is very interesting. You see, n plus L is same. So I told that n plus L, lesser means energy is less. Now if n plus L comes out to be same, listen to this very carefully. If n plus L comes out to be same, then you will decide based on the n value. Okay. So who has got less n value? 4p. Correct? So energy of 4p will be less than 5s. Okay. Lower the value of n plus L, but here n plus L is coming out to be same. Then you decide based on n value. So 4p will have less energy than 5s, right? So you will get questions like this one. In exam they'll ask you, like what is the order of n plus L like that. Let me take one more example now. Let me take 5s and 4p. Okay. No, sorry, I've taken the same 3d and 3d versus 4s. Let's see this now. Now for 3d, what is the n plus L value? 3 plus for d orbital 2. So what is the n plus L value? Or I'll do one thing, students, I'll write it there. Be more clearer for you. Okay. So I'll do it here. 3d versus 4s. Just see now. So here n value is 3. So 3 plus for d 2. So what is the n plus L value? 5. Okay. Yes, 2 for d orbital, right? So you'll get 4 here. Now here it is very easy. So obviously, n plus L is less for this. 4s, is very less, right? So 4s has got less energy compared to 3d, right? 4s energy will be very low. 4 is n plus L, right? Okay. So this is how you decide the energy. Okay. So you will get questions like this, they'll give you some orbitals, they'll ask you like which will be filled first. Okay. We'll do some questions like that later on. Fine. This is one thing. Then second thing is, this is Obbo's rule, right? Next thing is Pauli's rule. This is also called Pauli's exclusion rule. Exclusion principle. Okay. Now what this states, just see very carefully, it's very interesting. This states that no two electrons, okay, can have all the 4 numbers same. Can have all the 4 quantum numbers, right, same. Very, very important. So that means if you take 2 electrons, right, okay, for those 2 electrons, all numbers should not be same. It's something like, if you say that all the numbers are same, right, then they have got the same address. Okay, that is not possible. It's not possible. At least there should be a difference in at least, one of them, right? Puja, some difference. Is also different. Some quantum number should be different. Like I'll give one example now. You see, for example, first electron. See, n is equal to 3, L is equal to 2, Ml is equal to -2, Ms is equal to plus half. Okay, first electron. These are the 4 quantum numbers, right? Now I am going for the second electron now. N is equal to 3, L is equal to 1, Ml is equal to, okay, Let me take -1, right? Clear? MS is half. Now, sure, this is allowed. No problem. Why? Why is allowed? Tell me. Because you see, there's a difference in L. There's also a difference in ML. Good, allowed. Not a problem. There should be some difference. So here you have got difference in both. Even difference in one is allowed. Okay? Like I'll give one more example now. Just see. Suppose you have got n is equal to 3. Clear? And now I'm writing for the second electron. For second electron, I write n is equal to 3, L is equal to 1. Remember, both are plus half. Both are plus half, right? Okay. First thing, student, when you're writing this, you just check for n is equal to 3, can you have L is equal to 0? Yes, you can have. L ranges from 0 to n minus 1. Here also same thing. L ranges from what? 0 to n minus 1. So you can have up to 2, right? And ML will go from minus L to plus L. Okay? Yes, you can have that. Minus L to plus L, right? Here also. Okay? Now tell me, are these two allowed? Yes, they are allowed. Why? Because you see, everything is same, but there's a difference here. Can you see that? You see, there's a difference in L. Allowed. This is allowed. Not a problem. Okay? This is allowed, student, right? Not an issue. There's a difference in L. So there should be a difference in L, or there should be a difference in ML, or there should be a difference in N. Okay? Or if everything is same, at least there should be a difference in EMS. Clear? Yes. At least MS should be different. Fine. So that is what Pauli is telling us, right? So suppose you write like this, L is equal to 0. This is for one electron, right? First electron, right? Now second electron, I'm writing like this. Please understand, and if you have doubts, you please ask in the Zoom class. You can ask in the Zoom class, right? Now you see here, now everything is same. Can you see? But yes, there's a difference in EMS. So sometimes, everything comes out to be same, right? But MS should be different. What's the meaning of this? That means in one box, in one orbital, right? See, in one orbital, one box, N is same, L is same, ML is same, one box means. But MS should be different. MS different means what? One should be clockwise, other should be anti-clockwise. Are you student getting it? So ஒரு பாக்ஸ்ல வந்து ரெண்டு தான் போட முடியும். One clockwise, one anti-clockwise because MS will be different. Okay. If you are doing it like this, student, this is wrong. Why wrong? Because you are taking two electrons, see same quantum numbers. Can you see? When you draw a box, no, N, L, ML are same. This is wrong. That's the reason why I'm telling you that one box can take maximum two electrons only. This is coming from this Pauli's rule, right? Clear? So I hope you're getting why this is wrong because these two will have same numbers. Okay? Okay, son. This is about Pauli's rule, right? I hope you're getting it. So you can get a lot of objective questions on this. Just give 1 minute. Now the next rule, student, is called Hunt's rule. Okay. Let's see this now. What is Hunt's rule, right? Very important rule. Now, Hans Rule states that when you have got degenerate orbitals, listen to this very carefully, students, right? It's very important. Suppose I'm drawing px, py, and pz. Okay, all these three have the same energy. Energy wise, they are all same. Only orientation is different. Clear? One is, listen here, one is along the x-axis, right? One is along, but orientation is different. But energy wise, they are all same. So all of them have the same energy. Okay, all have same energy, and therefore they are called degenerate orbitals. What are they called? Degenerate. Degenerate means same energy. Okay. In such a case, when you are filling electrons, this is very carefully for degenerate orbitals, right? Same energy. When you are filling electrons, right, you fill single, single, single with the same spin. Okay. Suppose I have to fill. Suppose I have to fill two electrons. Then how do you fill it? You will fill like this. Two boxes, right, with same spin. Suppose I have to fill three electrons, student, right? Three electrons I have to fill, then I'll fill like this. Okay, fine. Only when you're filling it like this, see, you will get maximum spin. So what is the spin here? Tell me half, half, half. So you will get spin how much? 3 by 2. Okay. If suppose you fill like this, then what will happen is half will cancel with this half. So half minus half, right? And then you will get one more half. So what is the answer? You will get finally half. Clear? So here you will see you will get less spin. Here you will get more. You will get maximum spin. And that's what Hunt is telling you, that whenever you are filling electrons, right? Okay. But please remember, students, in degenerate orbitals, you will fill single, 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 right? Okay. First you will make them all unpaired, right? So you'll get maximum spin. Okay. And there's a reason for this, student. Why? Because if you fill like this, the electron can jump from one place to another place. It can exchange. In the electron, listen here. I'll tell you now. This electron can go here, this electron, they can keep exchanging. Can you see that? There are three places, Electron can keep going from one place to another place. And that, listen here, that will make the system stable. Make it very stable. Okay? A lot of exchange will happen. The energy that comes out of this, right, is called exchange energy. Okay? Yes. The extra stability that you get because of this, because of exchanging places, is called exchange energy. Students, if you remember Heisenberg, principle, Heisenberg told that electrons, should not be in one place. They should keep moving. So this is the best thing, if they want to move, this is the best arrangement you can have. Clear? They should keep moving. They should keep exchanging. That will make it stable. Here you can't do much exchange. Here, this is a pair. This is a couple actually, right? So this couple, can't go here. Because single. Just see very carefully. Single and here is a couple. Okay? So couple can't go and sit here. This is occupied by single, right? Here you can't have exchange. Okay? So the reason is, maximum spin. So what does the Hunt rule say? That whenever you're filling electrons, right, in degenerate orbitals, have the maximum spin. Okay? Now, of course, if you want to fill the fourth electron, obviously you have to fill like this. See, suppose I want to fill fourth electron, then what will I do? Obviously, I have to go like this only. There's no other option, right? And the fifth electron, right, like this, sixth electron. Then obviously you have to get paired up, right? Okay? So this is what is called Hund's rule. So just think about this. Okay? Like I'll give you some time, just think about this. So this is let's start now. So this is how you'll fill electrons and degenerate, right? Okay. Now what type of questions you will get in this? Let's see some questions, right? Suppose in exam they ask you a question like this, right? Okay. This arrangement they have given to you, okay? Clear? And they will ask you this arrangement violates which rule? Can you think, student? It violates which rule? Tell me. It violates Pauli's rule. You see this box. This box has got two electrons with same spin. So this violates which rule? Pauli's rule. Like this question will come. Suppose I give you an arrangement like this, just see now. Okay. I give you an arrangement like this. This violates which rule? This violates Abbas rule. Now why Abbas? Just see now why it is violating Abbas rule, right? Why? Because without filling the lower energies, remember this is a lower energy. You should fill first. You should fill two here. So be careful. Okay. See, one box can take two. Correct? Maximum capacity is two. So without filling this, you are going for this. Without filling the lower energy. This is lower energy, right? Without filling the low, you are going for higher energy, right? Okay? This is also not allowed. So you are violating Abbas rule. Fine? Think about it. Okay, sir? So in this case, you are violating the Abbas rule, right? Hmm? I'll give some more examples now because you can't go to this before filling this, right? Let's take some more examples now. Now I'll ask you one question. It's a very interesting question. This violates which rule now? It violates Abbas. Why? Because without filling this, you can't go here. So it violates Abbas, right? First, without filling, you can't go here, right? Okay, fine. Second, it also violates Hunt's rule. How it violates Hunt's rule? Tell me. Hunt's rule because if you are filling three electrons, right? Single, 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 you should fill. Fine. And remember, it also violates Pauli's rule. Why? Because Pauli told that in one box you can't have the same spin. Okay? In one single box, you can't put the same spin, right? At least, one should be up, one should be down. So student, this is how you do it. So it violates all the rules. Obbo's rule, because energy wise, problem, Hunt's rule, right? Okay? So this is how you'll do it, right? If you have doubts, you please ask in the Zoom sessions, right? Okay? So it is violating, students, it's violating all the three rules, right? Now let's take some special cases we'll take now, just Now if you take chromium, this is very interesting, student, right? If you take chromium, atomic number 24, you should actually write the configuration as 1s2, 2s2, 2s, 2p6, 3s2, 3p6, right? I'll write here now 4s2. Just check, how many electrons we have filled. 20 you have filled, right? Yes, 20. 24 you have to fill, right? So you have filled 24 now. Just check it out. 20, 24. So this is what is expected. This is the expected configuration, right? Okay. What is expected? But soon what is observed is, experiment, they have done, right? What is observed is, this first part will not change. First part is same only, no problem. Okay, now there will be a change. Just see now. Now instead of writing 4s2, you can write 4s1 and 3d5. You see the change here only, right? 4s2, 3d4. I'm going to write 4s1, 3d5. Right. Clear? I'm shifting one s electron, concentrate here, from 4s to 3d. Now why? Because if you write 3d5, it is half filled. Just see very carefully. 3d5, 1, 2, 3, 4, 5. Can you see this? 3d5, half filled you will get. And students, half filled orbitals, you can do a lot of exchange. The electron can go from here to a lot of exchange possible. Very stable, very stable. Okay. So half filled orbitals, please remember, they are very much stable. Because you can do a lot of exchange. Electron can jump from one place to another place. Okay. So what you'll be doing here is you'll be shifting one electron from this to this, right? 4s1, 3d5 and making it half full. Clear? Because half filled is more stable. Now students, you will ask me the question, sir, can we do it every time? No students, you can do only transfer from S to D, clear? Or you can do from S to F also. Suppose you've got F orbitals, right? You can do from S to F. You can do from S to D. Students, this only is allowed. Don't do everywhere. Just because you get half filled, right? Don't do it everywhere. Now you may again ask me, sir, why only S to D and why only S? Because you see the energy gap is not much. 4s2, 3d4, not much difference is there. Clear? So you can shift, no problem. Okay? It's not that difficult to transfer, for electron from 4s to 3d. Clear? But it is very difficult, students, to transfer from S to P. The gap is very high. Are you getting it? Very important, huh? You can't do it everywhere. You can do only in D block and F block. Nearest S orbital, you can shift it like this and make it half filled. Because half filled is more stable. Okay? Just think about it. Okay, student? So you can do this because it's more stable. Now, exactly, let's take one more example now. Copper. Now, here, it will be completely filled. So, copper, if you take 29, solid at copper, 1s2. Okay, I'll write here 3s2. I'll write here only 4s2, 3d9. Okay, this is what we expect. But what is observed? Observed is this part students will not change. The first part will not change. 1s2, 3s2, right? 3p6. Now the change will come. 4s1, 3d10. Now see your students, right? 4s2, 3d9. You are shifting one electron. 4s1, 3d10. Okay? You are shifting one electron from s orbital to d orbital. Now again you may ask, sir, why? Reason is completely filled d orbital or completely filled orbitals are very stable. Okay, completely filled. The maximum capacity of d is how much? Okay, complete orbitals, right? They are very much stable. The maximum capacity of d orbital is 10. So you fill all the 10 electrons. Complete, finish, very stable. Okay? Yes, highly stable, right? Are you getting it? So that's the reason why you are shifting from S to D. Because you get complete orbital, D maximum capacity is 10. That's stable. Fine. But again, students, here also you can do only from S to D and S to F. You can't do everywhere, please remember. Same problem. The gap is not much. In 4S and 3D, the gap is very less. Clear? So you can do only for D block and D block and F block, right? Fine. So I want to summarize now, like half filled orbitals, right? Half filled orbitals, completely filled orbitals, right? They are stable. Okay. So that's the reason why you can do this shift. Only for D block and F block, right? Complete, right? Okay. D and F block you can do it. Fine, students, then we'll stop here, right? So if you have any doubts, you please ask in the Zoom class. Okay then. Okay then. Bye then. Bye.